Hello and welcome back to Engineers Olympiad, where learning meets success. We're on to second chapter of surveying, that is theory of errors. We have completed the first chapter, that is introduction and basic concepts of surveying. And in the last video lecture held on the same topic, theory of errors, we discussed various errors, how they occur, what are their nature, and what are their types. And we also learned that there are three types of errors: mistakes, systematic errors, and accidental errors. Mistakes are also known as gross errors or blunders. Systematic errors are also known as cumulative errors because they are cumulative in nature. And the third type, the accidental errors, these are also known as random errors or compensating errors because they are compensating in nature. All right. And we also learned that while our systematic errors definitely follow some well-defined mathematical or physical law, these accidental errors, they do not follow any mathematical or physical law, but they definitely follow the laws of chance or the laws of probability. All right. So this forms the topic for today's video lecture, theory of probability. All right. So our accidental errors follow the laws of probability as already discussed because these are random in nature. That's why they're also known as accidental errors or random errors. But before applying the theory of probability, we have to make sure that all the mistakes are eliminated and all the systematic errors have been corrected. All right, students? So before applying the theory of probability, we have to make sure that all the mistakes or gross errors or blunders have been eliminated and all the systematic errors have been corrected. All right? And as already discussed in the first video lecture of this topic, we studied about true value. And the true value of a quantity is that value which is free from every error. All right. So the true value of a quantity is a value which is absolutely free from every type of error. But this is a hypothetical quantity and we can never assess a true value of any measured distance or any measured angle in survey. This must be noted by the students that this true value of a quantity which is absolutely free from every type of error, this is a hypothetical quantity and its value can never be assessed because we can never determine a true value of any measured distance or any measured angle in surveying. All right. And the difference between true value, the difference between measured value and the true value of a quantity is known as true error. All right, students. So the difference between measured value and the true value is known as true error. But since we can never determine true value of any quantity, that means we can never determine true error. All right. But using the theory of probability, it's possible to determine a value which is known as, I write it here, most probable value. Using the theory of probability, we can determine a value which is known as most probable value and this value has the property that it is more close to the true value than any other value. All right. Instead of true value, which is a hypothetical quantity we cannot determine, we use a value which is known as most probable value. And this most probable value has the chance of being the true value than any other measured value of a quantity. All right. So this forms the basis of the theory of probability. And let's study about residual. Residual is the difference between measured value and the most probable value. All right, students. So the difference between measured quantity and most probable value is known as residual, or it's also known as variation. All right. So this residual or variation is the difference between measured quantity and this thing, most probable value, which has the chance of being the true value of that measured quantity, unlike any other quantity. All right. Now, what is this most probable value? Most, if all the measurements of the same quantity have been taken with equal care and under the same conditions, the most probable value is equal to arithmetic mean of the measurements. Most probable value is equal to arithmetic mean of all the measurements. All right, students, and the residual is the difference between measured quantity and the most probable value, and this residual is also known as variation. All right. See in figure, this and this, these are the two normal probability curves. All right, and a probability curve is a plot between residual as abscissa. Our residual is also known as variation, and our error means our residual in a measurement, which is difference between measured quantity and the most probable value, which we take equal to arithmetic mean of all the measurements taken under care and under the same conditions. All right. So this figure, these two figures, they show the normal probability curves, and the probability curve is a plot between residual or error as abscissa and frequency of occurrence of a residual as ordinate, which is a probability. All right. A probability curve is a plot between residual as abscissa and frequency of occurrence of residual as ordinate. And you can see in these two figures, these two normal probability curves, that the first one, the flatter curve represents large scatter, and the largest scatter means low precision. All right. Large scatter means low precision, and in figure 2 of the normal probability curve, this figure, you can see that this is relatively a tall and a thin curve, and it indicates small scatter, and small scatter indicates high precision. High precision. So in this probability curve, large scatter means low precision, and in this one, small scatter means very high precision. And we must note some points regarding these curves, normal probability curves. The first one being that the positive and negative errors are equal in size and frequency. Let me write it down over here. Some important points regarding the normal probability curves. The first one being that positive and negative errors are equal in size and frequency. All right. They are equal in size and frequency because the curve is symmetrical. All right, students. So positive and negative errors are equal in size and frequency as the curves are symmetrical. The second point about normal probability curves, which you must note, is that small errors are more frequent than large errors. Small errors are more frequent than large errors. And one more point about these curves that must be noted by the students is that very large errors seldom occur. All right. So the 3 points that must be noted by the students about these normal probability curves is that positive and negative errors are equal in size and frequency as the curve is symmetrical. Small errors are more frequent than large errors, and very large errors seldom occur. All right, moving on, let's study about this thing, Gaussian distribution. Right, students? The normal or Gaussian distribution is the most important of all types of distribution. Gaussian distribution is the most important of all types of distribution, and it's also known as bell-shaped distribution. These curves are also known as the distribution curves or normal probability curves, and Gaussian distribution, which is also known as normal distribution or Gaussian distribution, is the most important type of all types of distribution, and it's also known as the bell-shaped distribution. These are the two figures which shows two normal distribution curves. All right, and these are similar to the curves shown over here. All right, and this Gaussian distribution can be expressed as this thing: y is equivalent to 1 by square root of 2 pi sigma e raised power minus 1 by 2 v by sigma square. Let me write it down over here. What do these terms mean? Y is the frequency of occurrence of residual or variation. Frequency of occurrence of residual, which is also known as variation, and it's the difference between measured value of a quantity and most probable value. As we also know, variation. All right. E is the base of the natural logarithm. All right. And sigma is the standard deviation. All right, students. So this Gaussian distribution or normal distribution or bell-shaped distribution is expressed as this thing, where y is the frequency of occurrence of the residual or variation, v is our residual, e is base of natural logarithm, and sigma is our standard deviation. And the standard deviation can be expressed as, let me write it down over here. Sigma is our standard deviation, and this can be expressed as all right, summation of v square divided by n minus 1, where v is residual, also known as variation, and n is the number of observations. V is our variation or residual, and n number of observations. All right, so we can express sigma, which is standard deviation, as square root of summation of v square divided by n minus 1. This standard deviation is also known as the root mean square error of a measurement. Let me write it down over here. We rub it first. Standard deviation. This is also known as root mean square RMS value of a measurement. Error, root mean square error of that particular measurement. So standard deviation is also known as the root mean square error of a measurement, and the standard deviation is normally used as an indicator to describe the reliability of a set of repeated measurements. This must be noted that this is an indicator. Which factor? Standard deviation is an indicator, and to describe what? The reliability of a set of repeated measurements. Thus, the smaller the value of a standard deviation, the greater is our precision. Smaller the value of standard deviation, which is also known as root mean square error of a measurement. This is an indicator to determine what? Reliability of a set of measurements, and smaller the value of standard deviation, the greater the value of precision. The more precise our measurements are, if our standard deviation is low. All right, and if the height of a Gaussian distribution curve is normalized so that the area underneath the curve is unity, the curve is called the probability curve. All right, if the height of the Gaussian distribution curve is normalized so that the area underneath the curve becomes unity, the curve is known as the probability curve. But although a theoretical probability curve requires a very large number of measurements of the same quantity, the curve obtained by few measurements is practically the same as the theoretical curve. All right, this must be noted by the student. If the height of the Gaussian distribution curve is normalized, such that area underneath it becomes unity, the curve is known as the normal probability curve. All right, moving on. All right, students. So this curve, the standard deviation, is an indicator to determine the reliability of a set of repeated measurements, and the smaller the standard deviation and greater is the precision. And we also learned if the height of the Gaussian distribution is normalized so that the area underneath the curve is unity, the curve is known as the probability curve, but that is theoretical. All right, and the standard deviation is our indicator to determine the reliability of a set of measurements. The smaller the standard deviation, the larger is the precision. Our precision is high and our measurements are quite precise. Now, the area beneath the curve bounded by the vertical lines presenting plus sigma and minus sigma. The area beneath the curve bounded by the vertical lines plus sigma and minus sigma. This is how much? How much is the area? 68.3% of the total area. So the probability of the error to occur becomes how much? Between plus sigma and minus sigma, 68.3%. Thus, an error equal to sigma is likely to occur roughly 7 times out of a set of 10. Students, please note this as the area in this curve bounded by the vertical lines between plus sigma and minus sigma is 68.3% of the total area. All right. Thus, an error equal to standard deviation or sigma is likely to occur 7 out of 10 times of measurement. All right. If we take a set of 10 measurements, an error equal to standard deviation is likely to occur. What is the probability of it to occur? 7 times. This must be noted. And if we'll take the second curve, all right, the area between the vertical lines presenting plus 0.6745 sigma and minus 0.6745 sigma is how much? It's 50% of total area. All right. So the error of how much? Plus minus 0.675 sigma is called the most probable error. And it's likely to occur 50% of the times. Most probable. All right. The area between the vertical lines representing this and this is how much of the total area? It's 50%. So the error of plus minus 0.675 sigma is called the most probable error. All right. Let's study some indices of precision. All right. Indices of precision. The first one being the standard deviation or sigma. What is standard deviation? It is an indicator to determine the reliability of a set of measurements. There are several standards which exist for assessing the precision, but the most popular is standard deviation. It's a numerical value which indicates the amount of variation about a central value. The amount of variation about central value is given by standard deviation or sigma, and there are several standards for assessing the precision, but the standard deviation is more popular, and the standard deviation establishes the limit of error bound within which 68.3% of the values of the set should lie. And as already told, sigma is under root of summation of p squared divided by n minus 1, where p is our residual or variation and n is the number of measurements. Let's study the second indices of precision. Variance. The square of the standard deviation is also called the variance. So it will be equal to, all right, this is our variance, the square of the standard deviation. And this V is equal to sigma square. All right. Variance is also used as a measure of dispersion or spread, but in surveying, we commonly use standard deviation. All right. This was about variance. Next one, standard error of the mean. Standard error of mean, this is equal to plus minus square root of summation of V square divided by n into n minus 1, where V is our residual and n number of measurements. And the sigma n is equal to sigma divided by root n. This formula plus minus should also be noted by the students. All right. The standard error therefore indicates the limits of error bound within which the true value of the mean lies, and there is a 68.3% certainty of it being correct. All right. I'll illustrate it once again, that the standard error indicates the limits of the error bound within which the true value of the mean lies, and there is how much? 68.3% certainty that it will be correct. This was our third indices of precision. The fourth one being standard error of a single observation. The standard error of single observation is does this seem familiar? This is standard deviation. All right, students. So the standard error of a single observation is equal to standard deviation, and the two terms are used synonymously in surveying. All right. Next one, most probable error. Most probable error is defined as the error for which there are equal chances that the true error will be less than the probable error, and there are equal chances that the true error will be more than the probable error. All right. What is true error? The difference between major value and the true value. And what is this? Most probable error, it is defined as that error for which there are equal chances that the true error will be less than the probable error, and there are equal chances that the true error will be more than the probable error. Or we can also say that the probability of the true error being less than the probable error is 50%, and the probability of the true error being greater than the probable error is also 50%. All right. And this most probable error this is equivalent to plus minus 0.674. All right. 0.674 under root of summation of v square divided by n minus 1. So this most probable error, you can also write it to another nearest digit. It is plus minus 0.6745. What is this? Standard deviation. All right. So the area beneath the probability curve between the vertical lines plus 0.674 sigma and minus 0.674 sigma is 50% of the total area. So the most probable error is also called as 50% error and is expressed as E50. All right. This most probable error is also known as 50% error and is expressed as E50. This was our indices of precision. Moving on, next one. Most probable error of the mean. Most probable error of the mean is plus minus 0.0001. All right. So this is the most probable error of the mean. Next one, maximum error. And this must be also noted by the student that the most probable error of the mean is 0.6745 times the standard error of the mean. All right. Next one, maximum error. These are our indices of precision because these give us the idea, or these are the indicators of how reliable our measurements are, or we can say how precise our measurements are. All right, maximum error. Since it's impossible to estimate the absolutely maximum error as the probability curve extends to infinity, all right, so we use generally 99.9% error, which is also known as E99.9. That is our maximum error, and in surveying it is equivalent to how much? Plus minus 3.29 sigma. All right, students. Since it's impossible to estimate the absolutely maximum error as the probability curve extends to infinity, so we rather use 99.9% error, or E 99.9, and it's equal to plus minus 3.29 sigma. And the most important thing is that this thing, maximum error, this is used to separate mistakes from random errors. How? This is used to separate mistakes from random errors. How? Because if any measurement deviates from the mean by more than this, if any measurement deviates from the mean by more than plus minus 3.29 sigma, it is considered as a mistake and that measurement is ignored, rejected. All right. So this maximum error is often used to separate gross errors from random errors. And if any measurement deviates from the mean by more than plus minus 3.29 sigma, that measurement is rejected because that is a mistake. All right. The various other errors and how they are related to standard deviation. Let's study them. Different percentage errors. And how they are related to standard deviation. First one, 90% error. E90. That is how much? Plus minus 1.645 sigma. All right, this is our E90. How much? Plus minus 1.645 sigma. Next one. 95% error, or E95. That is plus minus 1.96 sigma. All right, plus minus 1.96 sigma is our 95% error, also denoted as E95. Next one, 95.5. That is equivalent to plus minus 2 sigma. Our 95.5% error is twice that of a standard deviation, and our 99.7, that is E99.7, is plus minus how much? 3 sigma. 3 times the standard deviation. And we also studied the maximum error in 99.9, that is plus minus 3.29 sigma. All right, students. So this was about the theory of probability, the distribution curves, the normal probability curves, the Gaussian distribution, several indices of precision. With this, we complete today's video lecture. I hope it was informative, and thank you for watching.